In the previous section, we looked at networking and also saw a demo on services and ingress. In this section, we will look at temporary and permanent storage options, including storing configuration in Kubernetes. In this video, we will look at Kubernetes volumes. We deployed a static website and a RESTful API in Kubernetes, and in both those cases, we did not need to store any data. However, there are many situations where your application needs a place to store data, mainly for two reasons. First, to share data between containers. Second, to persistently store data even when container within a pod restarts. As an example, consider a pod that has two containers. One container has a web server and the other container continuously downloads data from a GitHub repository and puts it in a place that can be accessed by the web server container. Both containers would need shared space for storing the files. This shared space is called a volume. The volume is mounted on both containers and the mount directory can be different in both the containers. Even if the web server crashes and comes back up, it still has access to the mounted volume. The volume can be thought of as a directory, and this directory can be stored in multiple mediums. Although volumes are technically destroyed with a pod, however, if volume is created in a medium that is outside the pod, then the same medium can be reattached after pod restarts, and the data would still be available. For example, if your volume is created in an NFS share, then the NFS directory can be reattached after a pod restarts, and the data would be available. Kubernetes supports a few mediums by default. We will not discuss all of them, but here are a few. Empty-dir. This creates a directory when the pod starts and makes it available to the pod. It gets deleted when the pod dies. The directory is created on the same storage device that hosts the machine. The web server example that we saw earlier can use an empty-dir. Host path. This is something that you would probably not use in production. However, I mention it here because Minikube allows creating a volume of type host path, and we will see an example of it later. Hostpath mounts a directory from the host file system. For on-premise workloads, we could use NFS, which uses a network file system directory, Flocker, GlusterFS, Git repo, which mounts an empty directory and clones a GitHub repo. For cloud workloads, we could use GC Persistent Disk for Google, AWS Elastic Block Store for AWS, and Azure File Volume for Microsoft Azure. You can get a complete list from the Kubernetes documentation page. Let's look at an example of using a host path with our Minikube instance. We first create a directory called HTML and put our index.html file in there. This is how our HTML file looks. To make this directory available to Minikube, we can use the Minikube mount option or create a shared folder in VirtualBox. As seen here in the screenshot, I have mounted the HTML directory from within my machine to the /HTML directory in Minikube. Next, let's modify a static website YAML to use this directory as a document root for Nginx. We first set the volume in the pod specification. The volume name is HTML and the host path is the path in the host that we want to map in the pod. In our case, it's /HTML, which we mapped in the Minikube earlier. This volume needs to be mounted in the static website container. We add that as a volume mount with name as HTML, and the mount path is the path where this directory is available inside the container. /user local apache to htdocs is a document root for Nginx, and hence all files in the HTML folder on our machine will be hosted by the static website inside Kubernetes. Very neat. To deploy the YAML, use kubectl apply -f. We need the Kubernetes static website image in our Docker. If you are following along and don't have the image, you can build one from the Kubernetes static website folder. Let's see if the service is deployed. We can curl this service to see the output. First, we need to get the Minikube IP and then curl this IP on the node port. The index.html is the same that we created on our machine. If we edit the HTML page, the service should reflect that change. Let's test it. We change a line in index.html by adding a word at the end. We then curl the service again and the change is reflected in the website. I made a change in the file on my laptop, but since the static website was using my laptop's folder as a document root, the change is reflected immediately. This finishes our demo and the video on volumes. In the next video, we will look at persistent volume and persistent volume claim, which is a relatively new concept that allows maintaining volumes as a Kubernetes object. See you in the next video.